kiddos, today we're going to talk about classification of matter. And what classification of matter means is that we're going to take matter, and remember we talked about matter in our last video, and of course matter is anything that has mass and takes up space. Remember that means just about everything to us, not really everything. Energy, light, those things don't really qualify into our traditional definitions, at least of matter. But pretty much everything else is. The clothes we're wearing, the air we're breathing, the chair you're sitting on, you yourself, we're all composed of matter. And so part of what chemistry is, and chemistry obviously is the study of matter, we discussed that earlier in the year, and so part of what chemistry is then is breaking down the types of matter and then classifying them. And a lot of science in a bunch of different categories of science is about breaking things down into different categories. And so we're going to do that with matter. So let's break matter down into a couple of really broad categories. So I want to break this down into pure substances. Okay? We're going to talk about what each of these is and what that means. Pure substances and mixtures. And undoubtedly, you've discussed some of these things in some of your other science classes as to what those things are. And hopefully you use the same definitions, but maybe not. So I want to make sure that we've all got a fairly good grasp on what a pure substance or what a mixture is. So a pure substance means one type of particle. Now that sounds really weird, and one of the things that I want you to get in the habit of doing that'll give you a lot of success in the conceptualization of chemistry is not just to think about things like just, well, hey, I've got to think about atoms or I've got to think about electrons or whatever, but to think about things in terms of particles and then knowing what those particles are and how those particles interrelate with one another. So one type of particle in whatever we're measuring or whatever we're looking at, if there's only one type of particle there, then that means that it is a pure substance. On the other hand, if there is more than one type of particle, okay, and not more than one particle, but more than one type of particle, then that is a mixture. We're going to talk a whole lot more about mixtures in the next video. Most of what we're going to do in our video today is to sort of break down pure substances and make sure that you've got a pretty good handle of that. But mixtures mean that there are more than one type of particle. And so what do I mean when I'm talking about like, hey, let's look at these things in terms of particles? Well, let's say that I had a container and I had some particles in it. So I've got two containers here and I'm going to have two different things. So I've got a container that I'm going to have pure substances in and then a container that I'm going to have a mixture in. Well, in the pure substances then, if I've only got one type of particle, that might mean that I only have, say, one type of atom. And I've got a bunch of them in there, but they're all the exact same thing. Or also, I could say, hey, not just one type of atom, but what if I only had one type of compound in there, like one type of molecule in there? So what if instead of like saying, hey, I've got a bunch of helium atoms in there, what if I said instead that I've got water molecules in there? Of course, water molecules are H2O, so we can say that that's the O, and these are the hydrogens, and that I've got a bunch of those in there, okay? But what you'll notice is that each of the individual things here, that every particle that I have in here, okay, that every particle is one type of particle. It's all one thing. So, and what do I mean by that? Well, every one of these things in here, that is a particle, that is a particle, that is a particle, that is a particle. Those are all, in the case of what I've drawn here, they're all H2O molecules, but every particle is simply an H2O. These things are chemically bound together. So they could be individual atoms like we had initially with the helium, or they could be molecules, but it's one type of particle. If we had a mixture, then that would be as though we said, okay, let's go back and say, let's say that we've got water, okay? And so we've got our water molecules here. So let me draw a bunch of our water molecules. Okay, so that would be the oxygens again. And then we're going to go back in here and we'll put on some hydrogens so that we can see that each one of these is a water. And obviously I'm not really worried too much about all my bond angles and all that stuff. That stuff will come later. So as of right now, this looks just like that, right? So those are both pure substances. But what if I dissolve some salt in there, some sodium chloride? And then that sodium chloride is going to dissolve. And so also, in addition to all of the water molecules, let's say that I also have a bunch of sodium ions from the salt. Okay? And at the same time that I also have a bunch of the chlorides in there as well. Okay, and all of those things are dissolved into the water. And so when I look at this, I have a mixture. I've got a bunch of different types of particles. Not just a bunch of different types of atoms, but a bunch of discrete particles, separate particles that are not the same. Okay, and obviously I've sort of denoted that by making them different shapes and colors here. But that's not necessarily the case. It means that they are separate from each other. They're not chemically bound to each other. And one of the important things to know about mixtures, and again, we're going to talk about mixtures in the next video. We're going to talk about heterogeneous and homogeneous mixtures and all that stuff. But one of the things that's different about mixtures is that there are different types of particles in it. I've got one particle that's a water molecule. I've got a particle that's a chloride ion. I've got a particle that's a sodium ion. Each of those are different types of particles. I have 3 different types of particles in there. Now, I've got a bunch of different types of atoms, but I've got 3 different types of particles. When I look at pure substances, I've only got one type of particle in there. Everything in there is chemically bound together. So let's go back to pure substances then, and then let's break that down a little bit. Again, still continuing with our particle paradigm and thinking a little bit about the particles. All right, so we said we were going to break pure substances down into 2 different things. And again, I'm going to stick with my particle paradigm because I think it's really important that you get in the habit of thinking about these things in terms of particles. So we go back to the particle that we used in the last diagram where we had water in there. And we said specifically that water was molecules, right? And we already know that water is H2O, okay? And then it's got 1 oxygen and 2 hydrogens in each thing. And so the type of pure substance where you have more than one type of atom, and this is what's confusing sometimes for students. There's one particle, the molecule, but there are different types of atoms within that molecule. So there is an oxygen and 2 hydrogens then within that. And of course, so what do we call that? Well, those you may remember from previous science classes, those are called compounds. Okay? So compounds are a type of pure substance. So water, sugar, sucrose, that is a compound, but is a pure substance. You can purify that. It's down to one thing. There's only one type of particle in it. Now that particle is a molecule that has a bunch of different atoms within it, but it's only one single particle, okay? And so that's what makes it a pure substance. And then of course we can have pure substances where there's only one type of atom within that pure substance, and that would mean that that is an element. If there's only one type of atom within that, that is an element. Now, we also know from our atomic structure stuff that we could also say, well, technically they're different, like even if we had carbon atoms, there are isotopes of them, and that is true. So typically when we're saying that there's one type of atom, one type of element, we're speaking specifically that there's a standard atomic number for everything that's in there. So if these are helium atoms, they are all have an atomic number of 2. They have 2 protons in them. They are therefore an element. Of course, if something is an element, that means that it's something that you can find on the periodic table. Whereas if something is a compound, you could find the things that are in it on the periodic table, but you could not find the compound itself on the periodic table. There's no water on the periodic table, but there is hydrogen on the periodic table and oxygen on the periodic table. Those are elements that make up the compound. And again, you might be thinking in your head, well, how can this be a pure substance over here if there's more than one thing in it? It's because there's only one type of particle. There's one molecule in it. And that's another important thing that we need to know, and this relates back to what we talked about moles and all of those things, is that elements, the smallest unit for elements are atoms, and the smallest units for compounds are going to be molecules, or in some cases, and we're going to talk about bonding later, we'll talk about ionic bonds and stuff like that. In that case, we would say that the smallest thing are what are called formula units, which essentially are pretty similar to molecules for ionic compounds. They're not exactly the same because technically ionic compounds are made up of separate ions, but that's a relatively close approximation. So compounds one type of particle, smallest unit is a molecule. Elements, one type of atom, okay? Only one type of atom in there, and we can find those on the periodic table, and of course their smallest unit are atoms. Compounds, each of the atoms we could break down. And what also is important is to see that even though there are multiple atoms there in each particle, those atoms are chemically bonded together, and that's really important. So let me jump over to another thing that's really important about compounds here for us as well that you need to know before we move on. Remember that the other broad category of matter, that's what we're talking about today, is classification of matter. There are pure substances and there are mixtures, and we're going to do mixtures again in the next video. All right, so one last thing when we're talking about pure substances, we're going to talk a little bit about what a chemical formula is, what it means, because that's obviously going to be really important to us as we go on down through the year in chemistry. So sugar is a molecule that is called sucrose, okay, and technically we could break that down actually into two separate things if it went apart, but it's chemically bound together, okay? So if we were going to separate it, we would have to do chemistry to break it apart. We have to do a chemical reaction. We can't separate it by physical means. That's one of the things that separates mixtures and compounds from each other. So this is a pure substance. There's one type of particle. If you've got a bag of sugar, there should be one type of particle in it. Every particle in there is constructed of this particular chemical formula. So what does that chemical formula mean? So these numbers down here have a specific name. Those numbers are called subscripts. Okay, and subscript, if you remember your prefixes and stuff, sub means below. So subscript means a number written below the letter. Okay, so that's really important that you recognize that. And of course what that means then is that the 12 there means that I have 12 carbon, because that C stands for carbon, 12 carbon atoms. The 22 means that I've got 22 hydrogen atoms. Okay, and then I have 11 oxygen atoms. Now, you know how to do some of this before. We certainly talked about some of this when we did mole calculations and Avogadro's number and all that stuff, how to break those things apart. And what that would mean is that every individual molecule, remember this is a molecule of sucrose, contains 45 atoms of 3 different elements. There's carbon, hydrogen, and oxygen in that sucrose, and there are 45 total atoms in it. So you think, how is that a pure substance? Well, because when these are chemically bound together, they form one single particle that is a sucrose molecule. Okay? By the way, while we're on the topic of talking about subscripts and making sure that you keep things straight, it is really of super vital importance that you could say, recognize the difference between this and this. Okay? So you're like, those are the same thing. No, obviously they're not. That is a capital C and a capital O, and that is a capital C and a lowercase o. Any element, okay, any symbol for an element on the periodic table is going to have a capital letter first and then every other letter in it, and usually there's 2. Actually, I think they're all 2 now that we've named the last few elements. So the capital letter and then a lowercase letter, that means that that is an element. So these are 2 different things, and it's really important that you learn to distinguish between those. So this is a carbon and an oxygen, meaning that this is a molecule, okay? It's still a pure substance. It's a compound. It is carbon monoxide, and we'll learn how to name those later. Whereas big C little o, or uppercase carbon and or uppercase C and lowercase o, is not carbon and oxygen. Rather, that is cobalt. And if you looked on the periodic table, you would see that there is an element there named cobalt. Both of these things are pure substances. Both of these things would be one type of particle, but this is carbon and oxygen chemically bound together. This is one thing together. It is cobalt. So just make sure that when you're looking at stuff that you recognize that. Another one to look out for a lot, and I'll write this one up here real quick, is just to be sure that when you see something written, say, on a test, that you know the difference between, say, a Ci and a Cl. Cl, that's chlorine. Capital C, capital I is carbon and iodine, and so those are separate things. And I will tell you right now that if you can't tell the difference between them, and you're not, say, taking a state test or something like that, please ask all the time. This happens even in my AP class. I have students that sort of confuse that. And sometimes the font, if it isn't real clear, it's really hard to tell. So ask. Make sure that you know, is that a lowercase l or is that a capital I? Okay, so ask if you're not sure. Obviously on a state test or an EOC, we can't really help you with that. But outside of that, you should be able to tell pretty clearly by the font. If you can't, it's probably your teacher's fault for not making the font clear. And by your teacher's fault, I mean mine. Okay, so hopefully you got the basics of the first part of classification of matter, of knowing what pure substances are. Remember that pure substances can be broken down into elements and compounds. What makes a pure substance is there's only one type of particle in it. If there's more than one type of particle, then that's a mixture, and that's what we're going to talk about in our next video. All right? Thanks, kiddos.